Hello guys! We continue solving examples and exercises involving particles and objects with externally applied forces and acceleration, which are solved based on Newton's laws of mechanics. This is exercise number 9 of page 41 that states the following. In each of the following situations, the forces acting on the body cause it to accelerate as shown with magnitude a meters per second squared. In each case, find the value of A. So these are three situations of objects of given masses and external forces acting on them, each accelerating with an unknown acceleration A, where we are supposed to find the value of A in each case. Let's examine the situation part A. In this part, as in the whole exercise, forces and acceleration, that is motion, are only present along the y-axis. Since acceleration A is directed downwards, then the positive direction along the y-axis is downwards as follows. So according to Newton's second law, the net applied force is ma. Then F is equal to ma. In this case, there are several forces acting on the object. There is the 18 newtons force acting upwards, opposite to the positive direction, then it is negative 8. There is 2g downwards along the positive direction, then this is plus 2g. G is the gravitational acceleration. And this equation is equal to ma. A is the unknown acceleration, and m is the mass of 2 kilograms that's multiplied by a as follows. Then this is minus 8 plus 2 multiplied by 9.8, that's equal to 2a. This becomes minus 8 plus 19.6, that's equal to 2a. Then 19.6 minus 8 is 11.6, that's equal to 2a. Now let's divide both sides by 2. Then a is equal to 11.6 divided by 2, which is equal to 5.8 meters per second squared. So acceleration part A is 5.8 meters per second squared, found by applying Newton's second law along the y-axis. Next is part B. The mass of the object is 8 kilograms, with 100 newtons applied upwards, and the weight 8g is applied downwards for sure. While acceleration is directed upwards, then the positive direction is upwards. Again, the net applied force along the y-axis with the positive direction upwards is ma. So the forces acting on the object along the y-axis are 100 newtons upwards and positive. Then there is minus 8g, g is 9.8, acting downwards, thus negative, which is equal to m, mass is a, multiplied by the acceleration. Then this equation is 100 minus 78.4, that's equal to 8a. 78.4 is the product of 8 and 9.8. Then 100 minus 78.4 is 21.6, which is equal to 8a. If we divide both sides by 8, then a is equal to 2.7 meters per second squared. Finally, in part C, as you see, there is the object of mass 4 kilograms with 2 applied forces acting upwards, which are 30 and 20 newtons. In addition to the weight 4g, this is 4 the mass multiplied by the gravitational acceleration. And the acceleration is applied upwards, so is the positive direction along the y-axis, that is going to be upwards. Then the summation of forces is equal to ma. This is Newton's second law. The summation of forces is 30 upwards and positive, plus 20, also upwards and positive, minus 4g, that is 4 multiplied by 9.8 downwards and negative. This is equal to 4a, 4 multiplied by the acceleration a. Then 30 plus 20 is 50, minus 4 multiplied by 9.8, this is 39.2, which is all equal to 4a. Then 50 minus 39.2 is 10.8, that's equal to 4a. We divide both sides by 4, then the acceleration a is equal to 2.7 meters per second squared, the same as in part B. This is another exercise of finding the acceleration of objects with different applied forces along the y-axis. That's calculated according to Newton's second law.